just put it back there. There will be the guardian, but you all really need the sweets. Top by two today. I give top by two already. Oh, okay. Then you just stay long. Okay. Oh, I didn't know this door can open. And you never remind me that you never say when I sleep. Oh, okay. At least you all sleep Thursday, okay. Okay, so exercise 12.2 due Thursday, yeah? You all know the questions, right? Okay. Okay, let's continue with our product rule, and we aim to finish quotient rule today if it's possible. Okay, so when it comes to product rule, right? Okay, in summary, right, just to recap, okay, what we have already learned. Okay, we will keep the left, differentiate right, plus keep the right, differentiate left. Okay, so if I want to write it down in simple, so let's say if I have y equals to star times triangle. Okay, that means my dy over dx, you will keep the left, then after you differentiate the triangle. So I differentiate, I'll put the prime sign up. Okay, then plus keep the triangle, differentiate the right. Okay, so that will be summary, okay, about your product rule. Then last lesson, we were looking at exercise 12.3, question 1 and 2, right? I didn't go through them, correct? Okay, so let's just go through them today. Okay, so in your question 1, alright, so let us just let everything here be y. Okay, so 1a, our dy over dx will be keep left, differentiate right. Okay, then keep right, differentiate left, and we'll get this. Simplifying it, we will have 6x 3x plus 2 plus 3x plus 2 squared. There is no necessity in trying to factorize it. You can just leave your answer as such. Okay, what about 1D? What will your answer be, Joanne? What's your answer for 1D? Sorry, 4? 4 and what? 4 what? 2 plus x? 4 bracket 2 plus x. X squared plus x plus 1. This is your answer? You factorize, is it? Oh, okay. So this is your final answer lah. Right? Like I mentioned, no need to factorize. Okay, so keep the left, differentiate the right, keep the right, differentiate the left. Okay, so we would actually get 2x, 2 plus x bracket square plus 2x squared plus 2, 2 plus x. Okay, if you factorize out, I guess you would be getting this, but really I don't need the factorized form. Okay. Next, 2a. What would the derivation be, Nicole? You don't know what to do? Or you haven't do? Okay, Wayne? Huh? 2a? The answer? 2x to the power of half. Okay. Plus 1 over 2 x to the power of half. Bracket like that. 1 plus x like that. Square. Like this. Okay. So let's check our answer. In this case, keep the left, square root x. Differentiate the right. 2, 1 plus x. 1 plus, keep the right. Differentiate the left. So that square root x, that is half, x to the power of half. So half x to the power negative half. Okay. So actually, over here, that's correct. We could leave it in our square root form or our half to the power of half form, index form, that's also fine. Okay. Then over here, you may want to leave it like this. Okay. Otherwise, you could also write it as 1 plus x bracket square over 2 square root x. That is fine as well. Okay, as a fraction. There's no need for you to combine the two into one single fraction. No need of that at all. Okay, next, 2e. 2e is the one where yesterday I think some of you not very sure how to do. So we got to first simplify our question over here. Instead of having x square root x, which is difficult to handle when you have to differentiate this part of the bracket here, what we will try to write it as is square root x plus 2, or you can write it as x plus 2 to the power of half. X is to the power of 1, square root x is to the power of half. So we can add the powers together, we will get x to the power of 3 over 2 plus 1. Okay? Then we apply our product rule. Keep left. Differentiate right. Then keep right. Differentiate left. Simplify our answer. Can express it into third form. So this is a square root x in the numerator, square root x plus 2 in the numerator. Over here, you will get 2 square root x plus 2 in the denominator, and x to the power 3 over 2 plus 1. Okay. Alternatively, you could definitely write this as x square root x. That is fine as well. They mean the same thing. Okay. Any questions? Otherwise, let's move on to question 3. Okay, in question 3, we want to, or rather in the question, it says first express the function as a product of two factors, then differentiate it with respect to x. So why is it that I need to put it as a product of two factors? That's because my product rule is strictly only applicable if I have two things multiplying together. Okay? Whereas over here, I have 3 because I have 1 over x, x plus 1, and the other one is x plus 2 to the power of 3. Okay? So I need to work my way around such that I have it as a product of two things, then I can apply my product rule. Okay? So how do I go about simplifying this? Let's just do our convention to start it out first. Let y equals to this. Alright? We are looking at 3 things multiplying together. Do I have to take 1 over x to multiply to everything here? That means I need to bring it into x, bring it into 1, bring it into x again, and bring it into 2. Do we do that? So what do you think? No, okay, so what I can do instead is 1 over x, I can just bring it into this first bracket over here. Because it is easier since there is no power. If there is a power, then it will make things very tricky. Okay, because you will then have to expand it first before you bring it in. Or maybe to use some form of loss of indices. Okay, so in this case, we can bring it in. So 1 over x times x, that will give us 1. 1 over x times 1, that will give us 1 over x. So we see it as a product of two factors now. Then I can apply my product rule. Okay, the differentiation of 1 over x is your negative x power negative 2. So differentiation of the x power negative 1. Okay, then now we simplify it. So 3, 1 plus 1 over x, x plus 2 squared, minus x plus 2 cubed over x squared. Okay. Okay, next we look at question 6. So we have this equation of the curve. We want to calculate the gradient of the curve at each of the points where it intersects the x-axis. Okay, so when we look at intersection with the x-axis, what does this link us up with? What can we imply from here? When we say intersect, a curve intersects the x-axis, y will be equals to 0, right? Okay, so we will look at the points where y equals to 0. Okay, so we can actually find out what is the x coordinate, right? And then we will be able to find the gradient. Okay, could I just give you maybe about 5 minutes, right, to move around this question? Okay, shall we check what is our gradient answer? Jaron, what do you get for your gradient and at which points? Sorry, I can't hear you. 1106. Okay, at the point 10, yes. Gradient is 6. And then? Then your next gradient is negative 8. So you got 6 and negative 8. Okay. Any other answers? Gobin, what do you get? You got 0 and negative 8. Wayne, what do you get? Negative 4. 6 and negative 1. 6 and negative 4. Okay, seems like we have a variety of answers. Alright, let's just check our work, right? So we differentiate. Okay, keep the left. Differentiate the right. Keep the right. Differentiate the left. Okay, so simplifying this, I will get x plus 1 cubed plus 3, x plus 1, x minus 1 squared. Okay, we want to find at y equals to 0, what is the coordinate? So, at y equals to 0, we are looking at x minus 1 cubed and x plus 1. So, if it's equals to 0, that means x minus 1 cubed is equals to 0, or x plus 1 is equals to 0. Okay, so x minus 1 cubed equals to 0 would suggest that x minus 1 must be equals to 0. Therefore, x must be equals to 1. Okay, so the 2 points are 1 and negative 1. Alright, then now let's look at x equals to 1. Our gradient. Substitute 1 inside here. Okay, 1 plus 1 is 2, 2 to the power of 3 is 8. Over here, 1 minus 1 is 0, so down here should be 0. So actually we should be getting gradient to be 8 at x equals to 1. Okay, next one, at x equals to negative 1. Yeah, very wrong, something. Am I wrong? One minus one where? This one? Oh, I wrote this wrongly. Sorry. Okay, sorry. So nothing else wrong, right? So this one will become 0. Then this one will become negative 8 plus negative 1 plus 1. Negative 1 minus 1 square. So negative 8. Okay, so your gradient should be 0, otherwise negative 8. At the respective points, 1 and negative 1. Okay, so please check where your mistake lies. Right, let's look at question 9, last one for this topic. So we are given y equals to x squared minus 1 over x squared plus 1. We want to find the y coordinate of the point where dy over dx equals to 0. So this question will help us to go into understanding and appreciating our quotient rule later on. Okay, so in this case, because you're looking at division, we can also understand our y as a product of x squared minus 1 and x squared plus 1 to the power of negative 1. So you can rewrite this into this form. Okay. Later on, you may actually be using quotient rule and learning quotient rule. Quotient rule looks slightly more complicated. Okay. So there may be a chance that you want to actually stick to using product rule all the time. If you were to translate it into this form, that is fine as well. Okay, so there's nothing wrong with actually having to translate it into a product of two terms. But you should still learn your quotient rule because it is still helpful in some sense. Okay? So now we find our dy over dx. So keeping the left, differentiate the right, plus keeping the right, differentiating the left. Simplifying this, I would get negative 2x, x squared minus 1 over x squared plus 1 squared plus 2x over x squared plus 1. Okay? We want to find the y coordinate whereby the gradient is equals to 0. So that means if this is equals to 0, alright, what I can do is I can multiply across, okay, your denominator, or rather to balance both sides by multiplying the lowest common multiple of the denominator. So we multiply x squared plus 1 squared instead. Okay, meaning to say I'm actually looking at combining it into one single fraction. Okay, if you always think of like trying to transfer this, take note down here is a 0. Please don't transfer this over. It should still be a 0 equals to negative 2x, x squared minus 1 plus 2x, x squared plus 1. Okay? Then now we need to find the y coordinate. So we first find the what's the x coordinate. In this case, we need to simplify it. So what you could do is maybe to factorize. Okay? Because if you go about expanding it, maybe you will find it cubic. Okay? But expanding it might will also work out. Okay? There's nothing wrong with that as well. So what do you prefer? You want factorize or expand? Up to you all decide. Huh? Yeah, I know. Yeah, I just want you all to decide. Will you all prefer expand or factorize? Factorize? Expand? Expand? Factorize? Oh, it's your intuition. Intuition. Expand. Yeah, expand. So negative 2x cubed plus 2x plus 2x cubed plus 2x. So this one you expand. Negative and the plus will cancel out 0. So 2x plus 2x, yx. Okay? If you want to factorize, which sometimes may be useful, 2x, take out minus x squared plus 1 plus x squared plus 1. Minus and the plus will cancel out also. 1 and 1 becomes a 2, so we still get a 4x. Okay? Then, so we see 4x is equals to 0, that means x must be equals to 0. So, y is equals to 0 squared minus 1 over 0 squared plus 1. That's a negative 1. So the y coordinate is negative 1. Okay? Questions? No? Alright? No questions, that means got homework. Even if you got question, also got homework. Exercise 12.3. Question 2C, D, 3B, 4, 8, 10, 11. Since we are at that, I also want to inform you of your WA. Okay, AMAT on 25th February. Is this February? No. It's not even our calendar yet. Okay. 25th February. That's your week 8 AMAT. Okay. Testing on chapter 8, 12, and 13.1. Yep. Okay, so this one, you went Thursday? Is it too much? much. Then next week, even week, odd week, then the following Wednesday long. Okay? That is week 5, Wednesday. Week 5 Wednesday, not your holiday. Then, since we're at EMATS, might as well just tell your EMATS also. EMATS is 16th February, week 7, Tuesday. This one is Thursday, Tuesday. The express, you want the express match, same date. Okay. EMATS, chapter 1, 2. Okay. I know that at your second set 4 year, it doesn't affect your promotion. Okay. Your O level is the one that affects the promotion. But still make the effort to study lah, because you wouldn't want to be under at risk, right? Then more stuff for you to do. Not any of the first, right? Okay? So that's about the WA. Now let's look at 12.4. Okay, for quotient rule, right? We are looking at division. That means our star over our triangle. Okay, how to go about differentiating? Okay, this one complicated, So follow up. We will first keep the bottom, differentiate the top, minus away, keep the top, differentiate the bottom, then divide by bottom square. Okay? In quotient rule, it is very, very particular. We must start with bottom, then top, top, then bottom. Okay? So bottom must start first. Because this is a minus. 2 minus 3 and 3 minus 2 is different. Right? So that's why it matters. So bottom, top, top, bottom. Okay? Then bottom, square. So this one differentiate, differentiate. Okay? So, as I mentioned, product rule and quotient rule, they are not intuitive. Okay? Just to show you, dy over dx just now, when we did the fraction one, it came out very long. Okay, then after that, we got this as our answer. Okay, or rather, we combine it into this. Okay, so this was our dy over dx. Let me just erase from our previous question, where we were looking at y equals to x squared minus 1 over x squared plus 1. So this one where we use product rule. What if I use quotient rule? How does it look like? Okay, if I use quotient rule, I will keep the bottom first, which is x squared plus 1. Differentiate the top, 2x. Minus away, keep the top. Differentiate the bottom, 2x. Then over x squared plus 1 squared. Okay? This, you may be wondering, how come down here start minus 1? It's actually just a turning up, okay, flipping only. This one come forward, this one at the back. So it's exactly the same thing. Okay? So when it comes to product rule, it may take some steps in trying to simplify, especially when there are more parts to the question that require you to actually arrive at this. Quotient rule, you can immediately get it. Okay? But I just want to share the two of them because in case you forget the quotient rule during your test or the exam, at least, okay, product rule, I don't think it's that difficult to remember. Okay, product rule definitely easier to remember as compared to quotient rule. Okay, if you find this easy, then good for you, right? But at least you remember this, you can do all, right? That one is not an issue. Okay, so you can in fact use your product rule to check also. Okay, Joseph, can you please remain awake? I already offered sweets. What else can I offer? Okay, so let's look at some example. Let's look at try 9, page 18. Okay, we want to differentiate this with respect to x. I want you to give it a try. Use the quotient rule, okay, to differentiate this one. Sorry? Just read it out. So, 你可以 got 4 bracket 2x square minus 1 minus 4x plus 1 over 2x square minus 1 square. Okay? Do we get this? So, keep bottom, differentiate the top, minus away, keep the top, differentiated the bottom, bottom square. Okay, so this will be the answer. Likewise, okay, there isn't a lot of necessity. Let me see this one. Okay, it is not all the time that you need to simplify your answer. Okay, but in this case, right, if you take a closer look at the numerator, right, it can be simplified. Because down here quadratic, this one quadratic. Okay, so work on simplification. So we can expand it first. Okay, and we will have this. Then final answer, negative 8x squared minus 4x minus 4 over 2x squared minus 1 squared. Right. There are times where the question asks it to be in a specific form. So if you want to go and factorize the top, or in fact, you notice that in the numerator it's all negative. A good practice is to take out the negative sign. and leave it like this. Okay, so that's one good practice. Right, you may take out 4, okay, such that you get this, that's fine. But in general, I would say read the question carefully, look at what they ask for. If can simplify, simplify the numerator. Okay, next we look at our try 10, where the fraction itself involves some square root. And this is usually a more difficult task if you're not so strong in your indices yet. Okay, I'll write WRT to represent with respect to. Okay, just writing it in short. So in this case, you want to differentiate square root 2x minus 1. So if I were to differentiate that, what would I be getting? Kenneth? Bracket 2x minus 1. Power half. So you're trying to simplify it, is it? And the derivative will be half bracket power negative half equals to
1.
How come 1 eh? Oh, 1 over get rid of the bracket, okay. Square root minus 1, like that. Agree with this? Correct differentiation? No? Bervin, what's wrong? Okay, the 2x minus 1, is it? Okay, the 2x minus 1, remember inside the bracket also need to differentiate. So there should be a 2. So half times 2 will give you 1. So answer should be 1 over square root 2x minus 1. Okay. Next, part 2. Given this, we want to show okay. A typical question that involves quotient rule would look something like that, where they ask you to show, okay, or else they would sometimes say to actually express the answer in a specific format. So maybe they drop some numbers or some variables. Okay, so just keep a lookout at what the question wants. But general rule of thumb, try to simplify your answer as much as you can. Okay, so now that we have this, we want to actually find out what is the derivative. So based on quotient rule, keep the bottom, differentiate the top, minus away, keep the top, differentiate the bottom. So the derivative of square root 2x minus 1, you have already found it. Okay? But the problem is, this is a fraction. If you put another fraction over a fraction, sometimes it can be confusing. Although nothing wrong with that. Okay? So if you would like to, let's just do that first. Okay? So this is all in the numerator. Make sure your fraction line is long enough to allow the reader to be able to tell what is the main fraction that we're looking at. Then in the denominator, it will be the bottom square. Yep. Did I make a mistake? haven't answered the question yet. Yeah, of course, they ask you to show that this is not the answer. So this will be after your application of your quotient rule, yeah? Right? The tricky part is how to move from this to the one that you need to show. Okay, so let's work on simplification. So negative 1 square root 2x minus 1, I'll get negative 2x minus 1. Okay. This one here, you may want to put it into one fraction. Okay. Denominator, square root and square, they neutralize each other, so we have a 2x minus 1. Okay. But we're still not close to the thing that we want to show, yeah? Then how? Okay. So this is the algebraically challenging part. I erase this one. Okay. In the numerator itself, okay, you see this term and this term, this is a fraction. Combine it into one single fraction. So that means they should share the common denominator. It means that this part here, I must multiply with a square root 2x minus 1. So I will have negative 2x minus square root 2x minus 1 multiplying with another square root 2x minus 1. This minus sign belongs in between these two terms. It doesn't go to any of it. Minus away, 1 minus x. Must put bracket because down here minus. Then square root 2x minus 1. Okay? This is only the numerator. Don't forget the denominator, where I have a 2x minus 1. Okay? Now, let me ask you. If I have a over b divided by c, okay, it is the same as writing a over b over c, right? Which is the situation we're facing, correct? But in our basic algebra, we know that a over b divided by c is the same as a over b times 1 over c, right? Okay, so what does this simplify to? A times 1a, b times c, bc. Okay, so this must be equal to this one because they're equal, right? So that means when you face a situation like this, okay, you can take this denominator here, combine it with this denominator here because b times c. Okay, so I will have negative this times this, they are square roots of the same thing, so become negative 2x minus 1 minus 1 minus x. This and this multiply each other. I'll have this. Okay, so we're getting close to this. Our denominator at least has reached the same form. Simplify the numerator. So we are shown it. Okay? Any question? Right? Sometimes maybe they don't write it in this manner. They may write it in this manner. They actually mean the same thing. They have the same base 2x minus 1. Okay. Alright, any questions? Yes, Zhe Quan. This step to this step. Okay. You understand what I wrote here? You understand? Let me repeat. A over b divided by c, okay, is the same idea as a over b, a fraction, over c, right? Which is the situation we're facing here. A fraction over something, c. Okay, so A over B divided by C, I can also see as divide change to times C, I flip it one, so 1 over C. And this simplifies to A over BC. Since they are equal, this also must be equal. Over here all equal. So that's why I can draw the conclusion that this denominator, okay, I can bring it down and multiply with this denominator. Okay, so that's why I move from here to here. Okay. But just to be very careful, it must be one denominator for everything in the numerator. Okay, it must cover everything. It cannot be like one part fraction here, another part fraction here, and then you just anyhow mix things over here. No, it must be one single fraction in the numerator. Right? Any questions? Okay, so this kind of quotient rule application is very typical, okay, but algebraically challenging. Right? But once you get used to it, get a hang of it, you will be fine. Right? So, we got only 5 minutes. Can I give this as homework, then you all prepare as classwork? Can? Okay, I'll give you one question. One question. Okay, go back, try this kind. Okay, exercise 12.4, question 2D. Okay, go and try, practice. Okay, just go and try, do it in your notebook. Alright. I'll just end here today since I see that they are painting and I don't want you to inhale so much of the fumes. Okay, thank you class.